This video is going to look at how to solve systems of equations word problems using substitution. The AMC Bay Street Theater is offering a 3D screening of Toy Story 3 to celebrate NLS's 25th year. Tickets for NLS students cost $3 each. Tickets for friends and family cost $4 each. Teachers get in free. In total, there are 133 tickets sold and the theater collects $471. How many of each type of ticket are sold? So the first step in any systems of equations problem is to define your variables. So right here, often the question is going to tell you what your variable should be. How many of each type of ticket are sold? So what are the types of tickets being sold? There's student tickets. We'll call those D. And there's friends and family tickets. So we're going to have two equations that are going to use these variables, D and F. Step 2, write two equations. Often you will have one total equation and one money equation. Okay, so the total equation is the fact that there are 133 tickets sold in total. Nothing about the price of the tickets, just 133. So if we add the student tickets and the friends and family tickets, we'll have 133 tickets. We know that's true. We also know the theater collects $471. So this does have to do with the amount of money each ticket costs. The friends and family tickets, let's start with the student tickets. They cost $3. The friends and family tickets cost $4. So those are going to be our coefficients. $3 times the number of student tickets plus $4 times the number of friends and family tickets. That's going to equal $471. So we have two equations. The total equation, there's 133 total tickets sold, and a money equation. $3 times the number of student tickets plus $4 times the number of friends and family tickets equals $471. Step 3. In one of the equations, isolate one of the variables by getting it by itself. So we're going to take this first equation and we're going to subtract F from both sides. When we do that, we're going to get that the number of student tickets equals 133 minus F. And that makes sense because if we take 133 and we subtract away the number of tickets friends and family bought, we'll be left with the number of tickets that students bought. Step 4 is going to tell us to substitute or plug in the value of that variable into your second equation. Include parentheses when you're substituting. So this is the key step in substitution. And the logic is that if D equals 133 minus F, right? Then in the other equation where we see D, we can replace it with 133 minus F. Again, if D is equal to 133 minus F, then in this other equation, instead of writing D, we could write 133 minus F. So we're going to literally paste it in place of D. We're going to place in 133 minus F, and we're going to put parentheses around it. So it's going to look like this now. Now we have an equation with just one variable, F. When you have one equation with one variable, you're able to solve it. So step 5 is to solve this second equation to get the value of the variable. And we're going to solve it by first distributing. So 3 times 133 is 399. 3 times F is 3F, so we have this. 399 minus 3f plus 4f is 471. Now we're going to combine like terms. Minus 3f plus 4f becomes just plus 1f, or plus f equals 471. And now we're going to subtract 399 from both sides. To solve for f. And we get f equals 72. So we just found that there's 72 friends and family tickets sold. And the final step is to plug this answer, 72, back into either of our original equations to find the other variable. So I'm going to grab this first original equation, which tells us that in total there's 133 tickets sold, right? Now if we know there's 72 friends and family, we'll just plug in 72 for f, and we can solve for d by subtracting 72 from both sides. And we get d equals 61. So there were 61 student tickets sold and 72 friends and family tickets sold. So that's a lot of steps. One of the more complicated types of problems you'll see in 8th grade algebra. So we're going to do another example together. Involving burgers and fried chicken sandwiches. Justin's Burger serves burgers and fried chicken sandwiches. Burgers cost $5 and chicken sandwiches cost $4. Yesterday afternoon, Justin's Burgers sold 26 items and made 118 bucks. How many of each item did they sell? So our first step is always to define our variables. We're going to let b equal burgers and k equal chicken sandwiches. Right? That's what we're trying to find. How many of each of those did they sell? Next step is to come up with two equations. Our total equation is the fact that they sold 26 items in total. So b plus k is 26. Our money equation is going to involve the price of the burgers and sandwiches. So burgers are $5, 5b. Chicken sandwiches are $4, 4k. And that's going to equal 118. Notice all three of the money numbers got used in this second equation, 5, 4, and 118. Step 3 is when we isolate one of the variables by getting by itself. So if burgers plus chicken sandwiches is 26, right, then we could say that chicken sandwiches equals 26 minus burgers. Or burgers equal 26 minus chicken sandwiches. Either one of those will work. So it doesn't matter which variable over here we isolate and get by itself. I'm going to do k. Step 4, the step that gives this method its name, substitution. Right? If k equals 26 minus b, then we can substitute in 26 minus b for k. So I'm going to copy and paste this equation, but I'm going to replace k with what it equals, 26 minus b. And I'm going to put parentheses around it. Next step is to solve this equation. Now that we've substituted, we've created an equation with just one variable, which is going to be solvable. So we distribute, we get 5b plus 104 minus 4b equals 118. Now we combine like terms. We have 5b minus 4b. That's convenient, that's just one burger. Plus 104 equals 118. Now we're going to subtract 104 from both sides and we get 14. Now let's look back up at this equation. And let's take 14 and plug it in for B. So 14 burgers must be 12 chicken sandwiches because in total they sold 26 items.